So let me go ahead and talk about binary and then counting in binary. So we've got binary and we have decimal. So with binary, I only have two symbols that are allowed, 0 and 1, because it's a base 2. So what happens is it gets quite long. So to make it easier to read, I will group together my binary in groups of 8. And I'll have a space between them. So for me to write the value of 0, I would write 0, 0, 0, 0, 0, 0, 0, 0. So, and this also happens to coincide with the smallest size that you can have in Java or in probably almost any computer system or a computer language. It's 8 bits. So I'm going to go ahead and just fill it back. So if my first numbers are all zeros, then the decimal equivalent would be 0. So now my next number would be 1. The decimal equivalent would be 1. Well, I can only do 0 and 1. 0 and 1. So that means I have to go to the next position. 1, 0, which is 2. 1, 1, which is 3 decimal. Then I have to go over to 1, 0, 0, which is 4 decimal. Then I go to 1, 0, 1, which is 5 decimal. 1, 1, 0, which is 6 decimal. 1, 1, 1, which is 7 decimal. Then I filled all these up. Now I need to go to 1, 0, 0, 0, which is 8 decimal. So you can backfill these. But it's always good to do them in groups of 4 with a space between the other 4. Much easier to read because if you're looking at this many, so here's zeros. So now we go to 9, which is going to be 1, 0, 0, 1. Then we go to 10, which is 1, 0, 1, 0, which is decimal 10. Then 1, 0, 1, 1, which is decimal 11. 1, 1, 0, 0. Make that a 1. That's 12. Then 1, 1, 0, 1. That's 13. 1, 1, 1, 0, which is 14. And then 1, 1, 1, 1, which is 15 decimal. So one of the things that you'll notice is that these are positional. The binary is positional. So it's a base 2 positional, just like decimal is base 10. So we know that going back, and you've learned this from school, if I've got a decimal number and I go 10 to the 0 power, 10 to the 1 power, and 10 squared. And so 10 to the 0 is 1, 10 to the first is 10, and 10 squared is 100. So I take those values and I multiply 1 times 6, which is 6. 10 times 5 is 50. And then 100 times 3 is 300. So if I add them all up together, I get 356. Which most of you look at this and say, well, that's kind of rhetorical, Mr. Cusack, because I can look at this and it's 356. So what's important to remember here, base 10, is we have to look at the powers of the binary. So if I go over here, I'm going to go ahead and erase this just to make room. And I'm going to make it a little bit neater. So those are zeros, and each one of them is going to be 2 to the 0 power over here, 2 to the first power here, 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth power, 2 to the seventh power. Just like we did with our decimal, except for we used 10 to the 0, 10 to the first, and 10 squared. So let's look at what these values are. So 2 to the 0 is 1, 2 to the first is 2, 2 to the second or squared is 4. 2 cubed is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64. And 2 to the seventh is 128. So looking down at our example at 9. So if I look at 9 and I go 1, 0, 0, 1, this is a way for you to check to make sure you're on the right track. 1, 0, 0, 1, I'm saying that it's decimal 9. So if I say 1 times 1 is 1, 0 times anything is 0, so I have no reason to bring it down. So 0 times 2 is 0, 0 times 4 is 0, 1 times 8 is 8, so I'm going to say 8 plus 1 equals 9. So I got my value of 9. So let's look at another one. Okay, let's look at 13. 1, 1, 0, 1. I'm going to go ahead and erase this so we can take another look at it. So I've got 13. 1, 1, 0, 1. So 1 times 1 is 1. I don't need to bring the 0 down. 1 times 4 is 4. 1 times 8 is 8. And if I add them all together, $12, $13. So this is how you count. And you just keep on going, and when you can't, the next one after this would be 16. So 16, I would come over here. That would be 1, and then I'd have all zeros here. If you have any questions, let me know.